Okay, I said in a previous video, the one on drawing an atom, that atoms are like Lego bricks because you can stick them together. So let's have a look at how these Lego bricks can stick together. One way is ionic bonding. Now, if we look at this periodic table here, you can see on the left that to the left of that red zigzag line we've got all the metals. So most of the periodic table is metals. The bit on the right of that is non-metals. And ionic bonding is between metals and non-metals. If you get 2 or 3 or 4 different non-metals, that's called covalent bonding, and we'll do that later on. So ionic bonding is between a metal and a non-metal. So let's go for an example. Chlorine here, you can all draw this. We've got 17 and 35. Remember, we just round down to 35. So there are 17 protons. The whole nucleus weighs 35. So if the whole middle bit weighs 35 and 17 of those 35 are protons, you should be able to easily work out how many neutrons there are, and there's 18. Remember, the proton number and the electron number are the same. I've seen quite a lot recently of people saying there are 18 electrons. There aren't, there are 17. 17 protons, 17 electrons. So we've got 2 in the first shell, that's full up. We have to go on to the second shell, 8 in the second shell, that makes 10, that's full up. We have to go to the third shell, and there's 7. Okay, so by the way, you don't need to go through all that palaver. So if you look at this periodic table here, and I say how many electrons are there in the outer shell of a chlorine atom, all you need to do is find chlorine and see what group it's in. In this case it's in group 7. That tells you there are 7 electrons in the outer shell. So you don't need to go through all the trouble of drawing it out or thinking 2, 8 in the second, then how many in the third. Just look at your periodic table. What group is it in? If it's in group 7, that means there's 7 electrons in the outer shell. So if I said to you magnesium over here, how many electrons are there in the outer shell of a magnesium atom? You don't need to draw it, just look. It's in group 2. That means there are 2 electrons in the outer shell. Okay, so back to the story. So we've got our chlorine there, we know that. Now let's have a look at sodium. 11 and 23. So 11 protons, 11 electrons and 12 neutrons. 2 in the first, 8 in the second, and just 1 in the next shell. So what do we need to happen here? What do we need? Well, sodium has got that 1 electron in its outer shell, and the electron's got 7 in its outer shell. Now all atoms want a full outer shell. They all want a full outer shell. They want either 2 in the first and no more, or they want 8 in the second and no more, or 8 in the third. Usually they're trying to get 8. So how can chlorine on the right here, how can that get a full outer shell? Well, all it needs to do is get 1 more electron, change that 7 to an 8. If you give chlorine 1 more electron, it will be happy. It will be 2, 8, 8. It will be stable. It won't want to react with anything else then. So that's what chlorine wants. What does sodium want? Well, it could get 8. It could get 2, 8, 8 as well. Give it another 7 electrons. But that's a lot of trouble. What you can do is you can take that 1 off. Remove it. Pass it over to the other atom. Get rid of that whole shell, and now it's 2, 8, and it's got a full outer shell. Now everyone's happy. They've got 8 electrons in their outer shell. They're both very stable. So it's donated an electron across. Now, can you remember what charge electrons have got? They've got a negative charge. If I give you some negativity, what do you become? Well, you become negative. So chlorine forms a -1 ion, a negative ion, because it's been given another negative, another electron. Remember that electrons are negatively charged. What about sodium? Sodium has lost a negative. Now, if I take negativity away from you, what are you going to become? You're going to become positive. It's like if I take all your negative mood away from you, you're going to become a positive person. It's the same with atoms. So I take 1 negative off and you become plus. So sodium forms a +1 ion. Okay, now there's some questions later on this, so take note, right? So what if something lost 2 electrons? Okay, what if I took 2 negativities away from you? What would you become? You'd become 2 plus. What if I gave you 2 negativities? What if I gave you 2 electrons? You'd be 2 minus. So that's called ion formation. We'll get some practice with that later on. So if sodium forms a plus and chlorine forms a minus, opposites attract. Opposite charges attract, the two things stick together, and what do you get? You get sodium chloride. And that is how it happens. That is how they stick together, like in the sort of Lego model that I was talking about before. One becomes plus because it lost an electron, one becomes minus because it gained an electron, and because they're opposite charges, they stick together. So, this, when I was at school, this is something that I didn't understand. Only after I left did I sort of and became a teacher did I start to understand. Why do some of these weird chemistry hieroglyphics have a 2 on them, or a 3 or a 4, and some don't at all? I didn't understand that. Well, let's have a look. NaCl, you don't need to write the ones like this. You don't need to write Na1Cl1. It's just taken that it is 1. Okay, so 1 sodium goes with 1 chlorine. And I just showed you why. Because sodium wants to get rid of 1 and chlorine wants to gain 1. But what about magnesium? Let's have a look at magnesium. It's 2 in the first, 8 in the second, and 2 in the third. So what does magnesium want to do? How can magnesium get a full outer shell? It wants to lose those 2 electrons, doesn't it? Unlike sodium wanting to lose 1, magnesium could really do with losing 2 electrons. So magnesium, the atom, is going around saying, here, I've got these 2 electrons spare, who wants them? Someone take these 2 electrons off of me. And then chlorine comes along and says, well, I'm happy to take 1 of those electrons from you, and that would make me stable, so give me 1 of them. But then magnesium's still got another one, so it needs a second chlorine atom to take that off of them. So that's why 2 chlorines go with 1 magnesium, because magnesium's got 2 electrons to give, chlorine only wants 1. If magnesium wanted to get rid of 3, it would need 3 chlorine atoms to take it, and it would be MgCl3. But as the case is, it's MgCl2. And that's why there's a 2 there. Okay, that is a very, very quick run through of ionic bonding. Have a go at these questions. Pause it now and have a look at the answers. Good luck.